Section 3.4, Local Extrema and the First Derivative Test. In this section, we will define the increasing and decreasing intervals of a function, determine the critical values of a function, use the first derivative test to find local extrema of a function, and use this information to sketch a graph of the function. If x1 less than x2, f x1 less than f of x2 for every x1 and x2 in the open interval AB, then the function f is increasing on the interval AB. If x1 is less than x2, f x1 is greater than f of x2 for every x1 and x2 in the open interval AB, then the function f of x is decreasing on the open interval AB. Example 1. The graph of y equals f of x is given. Find the intervals on which a function f is increasing and the function f is decreasing. For part A, f is increasing. Part B, f is decreasing. When you look at the graph from point A to point B, as A is less than B, the function at A less than the function at B for all values the x between A and B. Or the other way, we say that the graph is increasing from point A to point B. So the interval AB is the interval on which the function f is increasing. Similar way, from point B to point C, the function at B is less than the function at C. For every x between B and C, the graph is going down or decreasing. So the interval BC is the interval that the function f is decreasing. From C to D, the graph is increasing. From D to E, the graph is decreasing. And from E to positive infinity, the graph is back to increasing again. Recall y prime is the slope of the tangent line. For the positive value of the derivative, or y prime greater than 0, that means the slope is greater than 0. If slope is greater than 0, that means the function f of x is increasing. For y prime less than 0 or negative in sign, which is the same as a slope less than 0, that tells us the function f is decreasing. The theorem, if f prime of x is positive, for all x in the open interval AB, the function f is increasing. For the f prime less than 0 or negative, then the function f is decreasing on the interval AB. Example 2. For the function f of x equals x to the third minus 12x minus 1. Part A, we find all values of x that correspond to horizontal tangent lines. These values occur where the derivative is 0. We call the derivative is the slope of the tangent line. First of all, we find the f prime, or the derivative of the function f. Apply the power rule. We get 3x squared minus 12 with the slope 0. For the horizontal tangent, we let f prime be 0 and then solve for x. Factor the 3 out. We have 3 times x squared minus 4 equals 0, or 3 times x minus 2, x plus 2 equals 0. We have two numbers, x equals 2, x equals negative 2, where the horizontal tangent lines occur. Which is the tangent line. Next part, we're going to use the value from part A, which is x equals 2 and x equals negative 2, to find the open intervals on which the function is increasing and the open intervals on which the function is decreasing. So we're going to use the number line to help determine the interval on which the f prime greater than 0 or f prime less than 0. We call the function is increasing for f prime positive, decreasing for f prime negative. Draw the real number line. Locate the number -2 and +2. And we're going to identify the sign of the f prime. Recall f prime is 3x squared minus 12, or 3 times x minus 2 times x plus 2. Pick the number on the right side of the 2. For example, x equals 3. The f prime at 3 will be 3 times 3 minus 2, 3 plus 2. That will turn positive in sign or greater than 0. Pick the value between -2 and 2. For example, x equals 0. So f prime at 0 would be 3 times 0 minus 2 times 0 plus 2, returns negative in sign. And the left interval, where we pick the value x equals -3, for example. So f prime at -3 equals 3 times -3 minus 0, -3 plus, -3 minus 2, and multiply by -3 plus 2. It turns out to be f prime at -3 greater than 0. From the sign plus minus and plus sign for each interval, we can summarize it as the interval on which the function is increasing. So f of x is increasing on the interval -infinity to -2, and also the interval 2, infinity. And then f of x is decreasing on the interval -2, +2. And then part C, we're going to sketch the graph of the function. From information that we got from part A, x equals 2, x equals -2, we get the horizontal tangent. Okay, and then between -infinity to -2 and 2 to infinity, the graph is increasing. -2 to 2, the interval -2 to 2, the function is decreasing. So plot the graph, draw the xy plane at 2 and at -2. For the function value, f at 2, we replace it with 2 to the third minus 12 times 2 plus 1. And then we get the value -15. For the function at -2, -2 to the third minus 12 times -2 plus 1, we get 17. So we get two order pairs. That tells you about the horizontal tangent. -2, 17, the horizontal tangent, and -2, this positive 2, -15 with the horizontal tangent. Find a couple more points for the y-intercept. X equals 0. Therefore, y equals 0 minus 0 plus 1, or y equals 1. So we got the order pair 0, 1 as the y-intercept. And we know that the graph is increasing from -infinity to -2, decreasing between -2 and 2. And then have a horizontal tangent at +2. Within the interval 2 to infinity, the graph is increasing. So we are done sketching the graph and look at the point where the graph has a slope as a horizontal tangent. Slope would be, this is -2, 17. Over here is 2, -15. And here is the better looking graph. Another example, y equals x to the third plus 1. Find all values of x where the derivative is 0. Part B, determine where the function is increasing and where it's decreasing. And part C, sketch the graph. For part A, find all values where the derivative is 0. Y prime equals 3x squared. Let it be 0. We get the x equals 0. That will give you the horizontal tangent. Let's find the order pair. Y or the f at 0 would be 0 to the third plus 1. Gonna be the order pair 0, 1, where the tangent line has a horizontal slope. And then part B, we identify the interval that the function increasing, decreasing. Draw the real number line, locate the point 0, identify the sign of the f prime, where f prime is 3x squared. Any value greater than 0, for example, x equals 1, the f prime at 1 equals 3 times 1 squared, which is positive. Pick the number less than 0, for example, x negative 1. F prime at negative 1 or 3 times negative 1 squared returns a positive as well. Therefore, f is increasing on the interval negative infinity 0 and 0 infinity. And the graph of the f is not decreasing at all. In part B, part C, we're gonna sketch the graph. As the graph that you see, the point 0, 1, whereas the tangent line is horizontal. On the left, from negative infinity to 0, the graph increasing, and then start to be increasing again after x equals 0. In this example, f of x is 1 over x. Part A, we find values of x where the derivative is 0. Part B, determine where the function is increasing and where it is decreasing. Part C, we sketch the graph. When we look at this function, it is the reciprocal function, or 1 over x. The restriction for this function is x cannot be 0. Therefore, 0 is not on the domain, or the function is not defined at x equals 0. Part A, to find the derivative, and then what value that make the derivative to be 0. First of all, the function f of x, which is 1 over x, we write it as a power form, or x to the power negative first. To find the derivative, f prime gonna be negative 1, x to the negative second, or negative 1 over x to the second. In this case, you can see that it will not be 0. But the restriction still similar to the restriction when we found the domain. That means x cannot be 0, but the slope will not be 0. It looks like 0 still the point of interest. So part B, we're going to find out the function increasing and decreasing on which interval. Draw the real number line, locate the point 0, the point of interest, and then identify on the left and on the right side of the point 0. In this case, we pick the value x equals 1. F prime for f prime, which is negative 1 over x squared. For x equals 1, we get the sign of the value which is negative inside. So we put negative sign here. On the left side of the 0, let's pick the value x equals negative 1. F prime at negative 1 is still negative inside. So both sides of the 0 point, the function, the f prime is negative. That means the graph is decreasing. Both sides of the point 0. To sketch the graph, as the function is not defined at the point 0, so that is the vertical asymptote. On the left side, the graph is decreasing. On the right side, the graph is also decreasing.